All right. Well, hello, everyone. Hola, it seems. Should be saying hola here. So my name is Shruti Chaturvedi. I'm a backend engineer at Gander. So at Gander, we are humanizing e-commerce. Well, we'll talk maybe a bit more about that later. But this session is about removing the hurdles of non-interoperability in your CI/CD workflows through event-driven standardization. So moving right on ahead, so the three ingredients for a successful system, and when we say successful, we're looking at three key vectors, agility, resilience, and scalability. And all these three components are super essential. So event-driven architecture is where we are decoupling our entire infrastructure so it can scale easily and it's not super dependent on other systems. And since our services are now decoupled, we need a way for all of them to be able to communicate and talk with each other, and that's where we bring in interoperability. So, however, interoperability without standardization leads to non-agility, non-resilience, and non-scalability. So we're going to talk and hear from great people about event-driven architecture and also about interoperability. But what I want to do is just focus a bit more on interoperability in the next slide. So different types of interoperability. So we have direct interoperability, and as Kara mentioned this in the first presentation, this is what we can correspond to integrations. And then we have indirect interoperability, which is really the true interoperability that we're looking at. So think of this in terms of example here is, I personally don't speak Spanish. And here, I might need a Spanish translator, someone who can speak Spanish for me. And if I go to Germany, I might need another person who speaks German and can help me translate with them. So, you know, it leads to a very large number of translators I might need as I keep moving countries. But an indirect interoperability would be just choosing something standard, a standard language where everyone can understand that, so that would be cheaper. So with direct interoperability or integrations, services get coupled tightly. And as we say, there's a direct dependence on that translator who's going to translate that for me, or translate that language for me, versus indirect interoperability, where there's no such direct connection. Direct interoperability, again, complex to scale because you need so many integrations, versus indirect interoperability scales independently of however many services or tools you need to communicate with. Expensive to develop. There's some math for everyone right here. So if we have 3 systems, we will somehow need like 3 integrations for each of those systems. Versus indirect interoperability, it's cheap because it does not need individual connections. It does not need to maintain all of those connections. So it's definitely cheap to develop and easy as well. So standardization, as we saw in the previous slide with direct interoperability, as our systems scale, direct interoperability too becomes uninteroperable. So what we really need to depend upon is indirect interoperability or standardization. And as it says in the slide, there is no alternative to set standards as workflows scale. And the alternative is just non-interoperable interoperability, or, well, chaos in our system. So standardization and event-driven approach. So when we're talking of event-driven architecture, we can look at it in 3 different components, or we have the event producers or the event consumers. Then we have the event itself. So where can we implement standardization? So the tool level is the first level where we can put in standardization. And this is because all of the tools, they each have different terms and technologies, even for very similar context. So they might be emitting very similar events, however, in different ways. So this is the tool level standardization, just standardizing the type of events coming in from different tools. Then we have the event level standardization, where we are standardizing the format of the event. So first we standardize the type of events coming from different tools, and then we standardize the format that the event will be in. And the routing level, of course, this is how the events are routed. We have different HTTP, Kafka, several different types. We're going to focus on tool level and event level interoperability in this presentation. So the first level, standardizing the format of events. So this is one of the components of standardization where we are going to standardize how the events are formatted. And and the tool that we are looking at is CloudEvents. And this is a specification for describing event data in a common way. So this is, again, not describing the type of the event, but once the event type is already described, this is just the format or how the event is going to look like. So what I'm going to do here is talk about CloudEvents Plugin for Jenkins, which was developed as a Google Summer of Code project last year. And a big shout out to all the mentors, Vibhav, Kara, Oleg, Andrea, the EventSig community, and the entire CD Foundation community. They've been very, very helpful and helped develop this super cool plugin. So what the CloudEvents plugin for Jenkins does is allows Jenkins to use CloudEvents as its event format. So this is still not sort of default. So you can have this plugin into your system, and then all of the events, or well, some events that we chose are going to be in the CloudEvents format. So Jenkins, again, this diagram right here emits a cloud event, and then it can be consumed by Tecton, Knative, Captain, or any sync that consumes cloud events. So what does the CloudEvents plugin for Jenkins do? Well, a couple of things. The CloudEvents plugin for Jenkins, first of all, the format of the events going in and out of Jenkins to or from other CI/CD systems is standardized. It's standardized because we are using the CloudEvents format, so it's just going to be a very similar. Here are the event headers. Here's where the event payload goes. And we are using the binary the content mode. I'll just talk about that in a sec as well. So the need to maintain tool-specific adapters to understand the varying event formats from different tools is eliminated, because so now we know what event or what format is that event that's going to come in. So for example, Knative, it does not need to know what is the format of that event because, well, it's a standardized event. So we do not, any of the tool which is going to be consuming this event from Jenkins does not need to know the specific format. So what we can do is build complex end-to-end pipelines extending multiple CI/CD tools which use cloud events. So again, leading on to a cheap and scalable process. You can scale this to as many tools and as many systems as you like, as long as your sync or as long as the consumer of the event can understand and can process cloud events. But again, the one big problem is the various events from Jenkins, they're still very Jenkins specific. They're not CI/CD or CI/CD tooling specific yet. So Jenkins specific still means that this is not adhering or conforming to any standards. You would have a build event very specific to how builds are represented within Jenkins. So any consumers who are interested in those events, build events, job events, pipeline events from Jenkins, will need to know Jenkins specific vocabulary. And they will also have to understand if the emitted events meet their intended purpose. And when I say that, I mean, each of the tool has very different terminology, so any consumer will need to know if this is exactly what I need and if this is what I need to act upon. So what has our journey been with the CloudEvents plugin? So GSOC projects are usually divided in two different phases, phase 1 and phase 2. Well, phase 2 really kind of took a turn, but with phase 1, the first thing we started off with was configuring Jenkins as a source. And this is where Jenkins will be emitting cloud events. So we had to look into event listeners, where can we get those events from. The second part was figuring out the type of events we need to send. And this was a problem because we had to first understand what events would other systems need, because there was no standard at that time. We were very confused at what other events in a CI/CD pipeline could be useful, or if we need to, again, adhere to certain standards and adhere to certain like standard specifications, what can that look like? What we did was just figure out all the events that Jenkins can send and just put it out there for anyone who wants to use it, but there were no standards as such. And structuring the event payload. This, I believe, too, was a bit of a problem because we just put in everything we can because there was no standard for the type of event that we had to emit. So without knowing what type a certain event belonged to, it became hard for us to understand what the event consumer might need. So the event consumer, for example, if looking for a build event, we did not know what standards do we need to conform to, what can the build event that the consumer needs would want to see in that particular event, a certain ID, a name, or whatever. So we just put in all the information we can in the event. And the phase 2 was just us understanding if we were able to achieve the final goal, which was, do we have loosely coupled interactions between Jenkins and other CI/CD tools, between Jenkins and Tekton, Jenkins and Captain, Jenkins Knative, anything that consumes CloudEvents. Are those interactions loosely coupled, or do we still need a lot to do? And again, can we work with other CI/CD tools easily? And are we tool agnostic, or do we still, as I said, need some form of integrations with Jenkins in order to get our events across and get the job done of achieving that multi-tool CI/CD workflow? So looking into the events supported by the plugin, as we said, what events are important and how to represent them. We, at that time, did not know because it was hard to tell what events should we send out, what events should a CI tool be sending out that other pipeline and other tools in the pipeline can use. So whatever we thought was important, we put in there, what can other tools need? Maybe queue events, maybe build events and node events. So these were some of the events that we started off with. We had queue events, job events, build events, and node events. And this was somehow taken from other tools and events that they supported. So this is before CDEvents, and we did not have any standard vocabulary or standard type where we can pull all of these events together and represent them. So strategy for event payload, as I said, we just put in a lot of data, more data than less, because we did not know what standard or what is the type of this event, so what can the other tool that is consuming this event can look for. So here is, for example, a queue event, and we just put in what that display, what is the name of the job that's in display, how long it has been in the queue, and all of that. So maybe it's not the most, or would have been the most relevant information, but we had to put in there just in case the person who is, or the tool that is consuming it might need it. Entering phase 2, and this was when we were asking ourselves, can the plugin now interoperate with, now Jenkins, can it interoperate with other CI/CD tools? And some of the questions that were in our mind, how will the other CI/CD tool use these events that are sent by the CloudEvents plugin? So we have Jenkins sending out CloudEvents plugin. Where is it going to go, and how is it going to be utilized? So, and the other question that we had were what will the event consumer need in order to process the CloudEvents plugin or the CloudEvents coming from Jenkins? We do send out the CloudEvents. Is there additional information that we need to put in there? Will the tool need to know certain specifics about Jenkins? So that was another question. And the last sort of encompassing all of that was, are we tool agnostic, or do we still need direct integrations between Jenkins and the tools consuming that event? So for that, we designed a proof of concept, which was inspired by the EventSig team. And inside the proof of concept, we had Jenkins sending out CloudEvents to the Knative CloudEvents broker. And this is essentially our event, we can say it's like a handler, which is where all of the CloudEvents are coming in. And on the CloudEvents, or the Knative CloudEvents broker, we had defined a Knative trigger. And a trigger is essentially, you can think of it as a filter. So you can define attributes of the events that you can filter and send it further down to the consumer or wherever the sink is. So the Knative trigger then sends the cloud events to Tekton, and Tekton trigger is again where you can extract specifics from that event. And then you can use those specifics inside your task run or pipeline run. Things like the name of the job that had just started, or the name of the build, or the artifact that is just finished. And then finally sending it on to the task run. So you would have that, you would receive that information and then act upon it, a typical event-driven architecture. So here is some of the information or some of that declaration files. So the knative trigger, defining the attributes, as you can see, this is directly from the event that's being sent. So this is going to be in the header or the CE type. This is the Tecton trigger, where we're just extracting information from the event that's coming into into Tecton, or into Tecton, that's going to be forwarded. And just the specification inside CloudEvents, where we are going to mention the sink. And here's just the information on where the sink is running. And the sink here is Knative, because we are first sending it to the Knative broker. So as you can see, the attribute here in type, or the Knative trigger, this is still very Jenkins specific. So we do want to filter out, maybe let's just say we have multiple tools. We have 10 tools, and all of those 10 tools are emitting some sort of queue events, like queue and something has entered the queue. And all of that must be sent on to Tecton, and Tecton want to act upon it. But for each of those different events, since there's no such standard for the event, we'll have to define a new attribute. We'll have to define this entire sort of filter for each of those different events. Some might be from, let's say, Tecton, and that's going to have a or not, maybe not Tecton, just some other tool that's going to have org.jenkinsx.ci.q or something. So it's not very standardized. It's a lot of work, and the more we scale, the more work and the more expensive it becomes. So this is where we were answering our questions, but still did not have a complete answer to them, but we were trying to see if coming out of phase 2, were we able to achieve what we wanted. So the first point here was just understanding, when we had built out the POC, that the building blocks of Jenkins and Tecton, they are not equivalent. And as you can see on the diagram here on the left, there's just still, for similar terms or same concepts and terms, the terminology used is very, very different. And the consumer of those events, they must be familiar with that tool-specific vocabulary. And if they're not familiar, again, the consumer does not know what it needs to do or what it should be doing with the event that it has received. So our plugin was not entirely tool agnostic. Well, there must be an N here, but yeah, the plugin was not entirely tool agnostic, still needed to know the specifics of other tools and the tool-specific entities and all of that. Yes, we did not need any additional adapter to consume the events, and that is where CloudEvents was very, very helpful, because there was a set format for how each event is going to look like. So this is very similar to if someone had sent out, let's say, a medical document, and everyone knows, well, the temperature is in Fahrenheit or is in Celsius, so you can easily translate that. So because the event was in the same format, it was very easy to translate. So no additional wrappers or adapters were needed to consume it. And it also made us think of Jenkins as a sink. For Jenkins as a sink, Jenkins consuming events, we too would need a lot of work in order to know the nuances of different tools we are working with. For example, if you're working with Spinnaker, if you're working with Tecton, we'll still have to understand what the different events or what those different entities they mean. So this is level O. This comes before we standardize the format of the events. We should be standardizing the type of events, because when then we come to level 1, which is the standardizing the format, we know that the event must not only adhere to the format, but it must also adhere to the type it belongs to. So this is the tool level standardization, where because we have multiple tools, each tool, different terminologies, similar events for those different terminologies or different concepts. So this is the tool level standardization, just standardizing right at the tool level. And here is where CDEvents, super, super helpful, and would have been very, very helpful if we did have in our plugin at that time. And how the lack of CDEvents affected us? Well, working with different tools and different terminologies meant that there was no similar concept, or there was no similar way of grouping. Some events made sense only for certain tools. So for example, if you had an artifact built or an artifact publish event, that would not make a lot of sense for other or down the pipeline. So how are we going to standardize, or how are we going to preserve? So there's a lot of ambiguity. And again, lack of compatible terms made design considerations very, very expensive. So if a particular sync is only interested in artifact built event from other tools, how it will have to set filters for each of those different tools, because there's, the event or the type, it's not standardized. Everyone may be representing it in a different way. And on the diagram right here on the right, we can see, even though, we have very similar tools, job started, or task run started, they're still represented in different ways. So bringing in CDEvents, again, this is where CDEvents would be very, very helpful. So considering Jenkins as a source, now we know the event, or now we know what Jenkins should be adhering to in terms of the events that it is publishing. We would also know what information should we be putting there, because we have an idea of, okay, here's how this is what that event means, and this is how it should be consumed. And Jenkins as a sync would have been, for someone or a consumer, anyone who is consuming those events, they would know exactly how to consume it, exactly what to do upon it, without needing additional information about those tool specifics or the tool vocabulary. So as you can see right here, we have different terms and terminology, so we are not changing that at the tool, we're just sort of grouping them together. So Jenkins job started or tech.event event task run just grouped under dev.cdevents.build.started, just adding a common terminology over tools, not changing the terminology of the tool itself. So, well, thank you so much. I'd now like to invite Oleg to come and take over. Really sorry, just... Okay. Okay, here you go.
Thank you very much. So thanks, Shruti, for the great presentation and for the case study from Jenkins. I'm proud to be a commenter in this project. So the main heavy lifting was done by Andrea, Mauricio, and by many other mentors, and Vibhav, who is also in the room, I believe. Yeah, hi. Yeah, in my case, I'm happy that we have so many projects focused on interoperability and cloud-native integrations in JSOC. And today, I'll just do a quick insight about what we want to achieve in Jenkins and Captain projects about CDEvents. Okay. So most of you probably know me. I'm a TOC member in the Continuous Delivery Foundation. I'm also board member in the Jenkins project. Recently, I joined Dynatrace to help with Captain growth, and currently I also contribute to Captain project quite a lot. I'm involved to a few other initiatives like Open Feature for open source feature flag management. If you want, we can talk later about it. So, and all my presentation is basically my own opinion. Okay. First of all, as we discussed at this conference and many other conferences, open source is for the win, as well as this. Open source standards are a must if you want to achieve interoperability and scale, if you want to integrate multiple vendors. And basically, if we talk about open source observability ecosystems, we already have a lot of standards available. So there is a lot of technologies out there. Obviously, CloudEvents, we already talked about, CDEvents, the emerging standard, also OpenTelemetry for all kinds of observability. And there is also a lot of open source tools using that. So this is basically an open observability standard. And for me, CDEvents contributes to this open observability ecosystem. It's not just transferring commands between one service to another, but also transferring insights, what cannot be passed through OpenTelemetry. OpenTelemetry has no events, but with CDEvents, you can actually do that. And for me, for CDEvents, of course, we need to push forward. We need to grow adoptions, and I hope to see alpha release of and public announcements of CDEvents soon. from the technical side, we are more or less ready. There is a lot of logistics to be done, also coordinating in the foundation. But we are getting closer to that, and hopefully maybe later this year or early next year, we will be able to reach general availability when all CDF member projects and also many projects outside the CDF start adopting this standard. For me, CDEvents is one of the key projects happening in the Continuous Delivery Foundation now. And we need to push adoption across the ecosystem. So you have a few logos there. These are just companies and projects that already declared intent to adopt CDEvents, and we need to keep working to grow this list. And once we have alpha release, then we will be able to actually make a lot of implementations and make it available to the industry. And then hopefully this standard will grow really quickly. So to keep it going, first of all, I would like to say thanks to the events SIG in the CDF, because thanks to them, we have this standard and all the ecosystem and actually all the interoperability initiatives. We inherited a lot from the AFL community, from other standards like Captain events that actually started various attempts to standardize the events, and CDEvents actually inherits that, and we need to keep it going to provide more standards in the industry so that tools could communicate to each other. So this CDEvents in general. Now I'll speak a bit on behalf of Jenkins project and then on behalf of the Captain project. So I'm wearing multiple hats today, well, but no real hats. Okay, so about Jenkins. Yeah, many people say that Jenkins is old. Every time I do a presentation on Jenkins, I say that Jenkins is not old, it keeps growing. And actually, it keeps evolving to be more and more cloud native. So if you use Jenkins in modern way, probably use pipeline as code, you use configuration as code, probably you already use Jenkins operator for Kubernetes, or Helm charts officially supported by the community. And also we have modern packaging for the platforms. We have various attempts like serverless Jenkins powered by Jenkins file runner. So Jenkins keeps evolving to address modern use cases and to be applicable in the cloud native world. For me, Jenkins still remains an automation server or framework, so there is no intent to make Jenkins a fully autonomous CI/CD system for cloud-native space, just because I don't believe it makes any sense. Jenkins, well, a cloud-native space is modular, and if you want to apply Jenkins today, it has to be modular too. At the same time, if you want to have a modular system, that you need a ecosystem, you need integrations, interoperability, and this is why investment in such an interoperability project was a key investment by the Jenkins community in the recent years. So if you open the roadmap, half of the projects somehow target interoperability, connecting Jenkins to other systems, and this is what was the main power of Jenkins for many years. For CDEvents, as Shruti said, basically, I can just repeat what we want to achieve. So firstly, we need to adopt a CloudEvents plugin so that it becomes CDEvents. So it becomes fully compatible with the standard once alpha version is released. There are still some changes here and there, some terminology alignment, but basically it requires technical implementation. There is no blockers to implement it right now. Also, we need CDEvents trigger so that we can control Jenkins from CDEvents, and I think that we also need a generic layer so that Jenkins can produce arbitrary CDEvents right from your pipelines, so that you can invoke arbitrary flows and use Jenkins as automation server, which is flexible and can be integrated with any tool. So this is what for Jenkins, and hopefully it will happen in the next year. We already discussed some bits in the community. We considered a GSOC project for this year, but maybe we'll start working in autumn. Then Captain. Who's familiar with Captain? Okay, so Captain is a data-driven orchestration tool for your cloud-native apps. So basically, it's not automation server like Jenkins. It does orchestration, and it sits on cloud events, receives these events, and acts on them, including processing data, processing metrics, and reacting on various systems, instabilities, and applying auto-remediation. So for us, it's also essential to adopt CDEvents in Captain, because currently, if you want to integrate any tool, that you need to have a specific format. And once we have unified CDEvents, we can just do it at once. And of course, once we have CDEvents, like trigger, etc., we can also control Captain using these events. Secondly, we need to produce CDEvents on our own because Captain is educated orchestrator with a lot of added value features. So we could automatically produce CDEvents for many common use cases. And this is what needs to be happening. Last but not least, Captain itself is a quite big modular ecosystem with a lot of orchestration. We support GitOps management for Captain. And of course, we need to produce CDEvents when we deploy Captain and its models so that you can observe how Captain itself operates at large-scale deployments. So these are areas we need to apply on the Captain side. But also, there is a side for the standard. Because when CDEvents started, when Event 6 started, Captain community also started contributing. Because historically, when we implemented Captain, when we open sourced it in 2019, there was already open specification for CloudEvents we used called Captain Events. This specification is very simple. You can see key events on the right. And actually, during the discussions, some of the beats formats have been already contributed to CDEvents. Now we actually need to do opposite, to adopt what is now in CDEvents to align. But one topic we observe in Captain is that there are many event types for application management and orchestration, which are beyond CI/CD events. So what I would like to see as Captain maintainer is that these events also become standardized so that it's not something we maintain and implement for any system, but something that everyone can adopt easily. And for that, for example, sending SLIs, SLOs, so if you work with set reliability, if you have evaluations for your target metrics, it would be nice to have these events. Also, common monitoring, alerts, it's not in CDEvents standard at the moment. Evaluations, if you want to do quality gates or the specific bits in your pipelines. And of course, any kinds of release and rollback operations, which is again not a part of continuous delivery, but it's a part of deployment, and it's only partially represented in CDEvents at the moment. So it's also something that we could adopt. And we were talking about having it open source and basically generalizing it as a standard, maybe as a part of CDEvents standard as a next iteration of that, or maybe creating a new standard within the CDF, so it's subject for the discussion. But this is something I would like to see in the project happening. So this is what we have for Captain and Jenkins. And just, again, thanks everyone. So thanks CDEvents, all contributors. Thanks Shruti for this plugin and for a lot of feedback we got on early stages of the project. And of course, thanks to all the Jenkins and Captain contributors who also made the implementations. So key takeaways from me, for you. So firstly, CDEvents is a great opportunity for the CD ecosystem, for the continuous delivery foundation, and we need to keep pushing it forward. So if you contribute to the CDF, or if you want to make your projects more open, consider CDEvents and try adopting them. Then for us, it's a joint interest. Yeah, there is a type between member projects and companies. So we believe that everyone should be contributing. And if there is benefit for you, you're welcome to join the community. It's fully open source on Slack. So Andrea already shared the links. And you're welcome to join us. Yeah, Jenkins and Captain plan adopting CDEvents earlier, so we are not going to wait until the GA availability, so hopefully we'll get another feedback from the field while implementing the standard. And again, if you want to basically have a seat at the table to contribute to the standard, if you discover any deficiencies, joining earlier at the alpha stage is what you would like to do. Okay, for today, if you do some discussions, just a few items. So whomever discusses announcements and adoption strategy, it's something you could do. As a TUC, as a CDF team, we are still accepting various marketing quotes. So if you want to share something for CDEvents announcements, please contact Emil or Andrea. We can add you to the list. Also, the CDF TUC dedicated $10,000 budget for evaluation of CDEvents. So basically, it means that we can run 2 or 3 programs, let's say as LFX mentorship, targeting CDEvents ecosystem, like documentation, reference implementations, SDKs, whatever. And to make it happen, we need mentors and we need contributors. So if anyone in this audience wants to participate, please reach out to me and I would be happy to work with you so that we get these programs running. Because these internship programs actually help a lot for the ecosystem. Again, an example of Shruti and her project, and thanks a lot. Also, application lifecycle events, if you want to chat. I'm here for 20 minutes before I run to the plane, so happy to discuss it too. Thanks, everyone. So I hope it was informative as an overview. And if you want to ask any questions to Shruti or me, now we have 10 minutes to do that.
Thank you very much, Oleg and Shruti. So Shruti, please come back up. Do we have any questions here in the room first? Was there a reason? No?
Silence.
No questions? Do we have some questions online? Let's see. Not that I can see.
Okay.
Yeah, here we have a question.
Yeah, hi. Very nice presentation, thank you. One question about the standardization things, what you mentioned in your presentation, that like the things do not need to understand the specifics of the events, but still we need to standardize the event types. So I see that there is, at least for me, there is a contradiction in that. So how is that working in reality? Like if the sync doesn't understand the new event types which are just defined, how it will, act on them.
So you're asking if, well, the syncs, they don't have to understand the event specifics, but how do they use that information from the, well, so, as we were, okay, let me maybe switch back and look here. So, for example, if the sync is looking for a specific, like a build start, that's what the sync is going to, that's what the sync is interested in receiving, only events of the type build started, right? So obviously the sync, if it has to pull some information from the event, it still would have to understand that, like if we are talking right now, right? So we're using a standard language, we both understand, like English, we both understand, okay, here's what this person means. But in order to, if you ask me a question, I'll still have to sort of think about it and answer it. So the sync still will have to process that information, but it does not need anything externally to understand, okay, well, this tool is sending me a build started. What does this mean? And for the source that is sending that event, it does not have to conform to, it's not specific to that particular tool. It's just a build started event. It's just out there. Anyone can use it without really knowing where it's coming from and without knowing the specifics of that particular tool. Like when we are looking at, maybe we can take a look at this slide right here, where there's difference in terms and technologies, right? You have a job in Jenkins, and in some other tool like let's say Tecton is called step. But the sync is only interested in, okay, a build has started. I don't care if it's a step or a job or whatever you call it. So the sync will still have to extract the information it needs, like the job name, the time that it was started, and all of that. So that's still the part of the sync. But the sync does not need to know where it's coming from, what the type or what the terminologies mean. Does that sort of answer your question? Yeah. Okay.
It also was mentioning that if we talk about modern CI/CD systems, the pipeline itself doesn't have to exist within a single system. So once CDEvents and other standards actually evolve, it means that the same pipeline can be distributed between multiple systems. So you could be passing pipeline context, similarly how you do with OpenTelemetry between projects. And then it becomes essential to have this standard. But on the other hand, it doesn't really matter for you as CI/CD engineer which pipeline engine is used within your pipeline. Because once you have a centralized system, you just have this system. And yeah, this is a key challenge for unification, because right now, even in Jenkins, we cannot really agree on some bits of the terminology. And yeah, hopefully we will get there.
Thank you, and thanks for the question. I think that makes the end of this session. We need to prepare for the next one. So again, thank you very much.
Thank you.
Thank you. Thank you, everyone.